Number 9.
Okay. In the system of equations above, k is a constant and x, y are variables. For what value of k will the system of equations have no solution? Okay, so when we say a system of equations, we could also say 2 lines, right? Or it could be more than 2 lines, but specifically to this question, we have 2 lines going on, right? Those are 2 lines in what form?
Standard form.
Standard form, very good. Specifically, when we have a system of equations with 2 lines and they have no solution, what does that mean about the lines? This is a very special case.
They don't intersect.
Correct. So what does that have to do with the intersection of lines, and specifically when they do not intersect?
They don't have a solution.
Well, right. But what else? What does it? How do we get down to the nuts and bolts of this thing?
Slope.
Slope, exactly. I don't know if that was an educated guess.
I was like, yeah, it sounds right.
It sounded like it had a question mark at the end of it, but you're correct. So it has to do with the slope, and the slopes have to be what in relation to each other?
Matching. They're the same.
They have to be equal, yes, absolutely. Because that would make a set of lines never, ever touch unless they were the same line. I guess I can erase this bit for number 11. Walk me through what, now that we've talked about it, what do we need to do here with these 2 lines?
Find the slope.
So we'll start with the second line there, and we just need to calculate the slope, and then we need to what?
Plug it back in.
We would need to kind of figure out how to make that slope work with the coefficient of x in that top equation, right? Which probably involves some plugging in, so I'll give you credit for that. All right, let's start with the second equation and let's get going here. We've got 4x minus 5y equals 7. We did this a little bit last week, and you're an honor student, so I'm going to kind of fly through this part. So we do that. All right, so what's the slope of this line?
4/5.
4/5, very good. That is the magic number that we're looking to make happen in this top equation here. So we have kx minus 3y equals 4. And let's solve this for the same slope-intercept form, and then we'll probably just be able to plug in some value of k, or I see a lot of fractions in the answers, so we may have to do something a little janky, but let's start there. So we'll subtract kx from both sides, and we'll get negative 3y equals negative. I'm going to leave this in slope-intercept form again to keep everything recognizable. So we have that. Divide that all by negative 3, and we end up with y equals negative kx over negative 3. I'm going to leave all the signs here. I know those would cancel, but I'm going to leave this stuff. You'll see why in a second, but if you'll notice, some of the answer choices have negatives in them. So I want to make sure that we get the right number, because you'll also notice that 2 of the answer choices are the same, just with a different sign. So we need to make sure we nail that sign, right? Do not want to leave it to question on a cancellation or what have you. So we have minus 4/3. That part doesn't really matter. Again, we're trying to end up with a 4/5 slope. So what do we do from here? So we can rewrite this as k over 3 times x, and then the rest, but it doesn't really matter. So then this becomes what we need to equal this slope for everything to work out the way we want. So what I would do at this point is set k over 3 equal to our desired slope. And then that should give us a value of k that makes this work out.
Yes.
Okay, so then we can cross multiply. I'm gonna scoot this over. So we get 5k equals 12, and then we can divide each side by 5, and x equals 12 over 5. What am I about to say to do before we circle answer choice A for this problem specifically?
Check the signs.
Check the work, yeah. So I'm gonna plug this stuff in. Again, positive 12 over 5 x. And you may, I'm going to also use this as an opportunity to show you something else. So when we have a fraction within a fraction, does that scare you?
Yeah.
Do you remember how I rewrote this other thing just a second ago? Like this? Just times x. How I just pulled it out of the numerator. Does this scare you a little bit less now that there's not an x in there?
No.
We still have a fraction within a fraction, right? So to deal with that, what we can do is we can do one of two things. Either we can acknowledge that this sign, what does this sign here mean? What does this line here, this horizontal line mean? Like if I write this, what does that horizontal line mean?
Out of?
Kind of, sort of, yeah, that's a good way. What would be another way you could say?
I don't know.
We could assimilate it with a division sign.
Oh, okay, yeah.
Yeah, like 2 divided by 3, yeah. So let's do the same thing here. This is just 12/5 divided by 3, right? Or, you know, with the negatives and everything. But that's basically, it still means the same thing. So we can handle this in one of two ways. If we divide 12/5 by 3, that'd be the same as multiplying times the reciprocal, right? So we got 12/5 times 1/3. Do you see how going from here to here is much the same as pulling this x out of the numerator?
Yeah.
So this is basically just the numerator, and then this becomes the denominator via multiplying by reciprocal kind of logic. And then from here, we can just multiply straight across. And that says 12 over 15. Remember, our target slope was not 12 over 15. So I'm going to erase this, actually. But we can reduce this to our target slope. So I think we're good. Oh, and again, I think this was negative, so all the negatives should cancel out.